Day 1, Intro to Piecewise Functions. We're going to look at this problem today, how much should Levi get paid, and then relate that to our new unit, which is piecewise and step functions. So here's the problem. Levi works in the shipping and handling department of a manufacturing company. He earns $18 an hour. If Levi works more than 40 hours, it's considered overtime, and he earns 1.5 times his hourly wage. All right, so number 1, how much does Levi get paid per hour during overtime? All right. So he makes $18 an hour, but then if he works overtime, he works 1.5 times that. So that would be $27 per hour. Let H be the number of hours Levi works in a week, and WH be his weekly wages. Can you find W of 15? So it would be, if he works 15 hours, how much does he get paid? And that's under 40 hours, so we're just making the $18 an hour. So this will be 18 times 15. So he's going to make $270. If he works 40, it's considered overtime, and he earns 1.5 times his hourly wage for any overtime hours. Well, if it's over 40, it's overtime, so this is still considered regular, as regular wage. So we'll do $18 an hour times 40. I'll make $720. Isla says that the equation for W can be written as W of H equals 18 of H. Do you agree? I would say yes if the number of hours is less than or equal to 40, because if it's greater than 40, it's 1.5 times that. Number 4 says, in the first 2 weeks of June, Levi worked 42 hours and 50 hours respectively. Can you find how much he earns if he works 42 hours? All right, so first I want to figure out, well, we know that for the first 40 hours, it's $720. So we can say 720 plus he worked 2 hours overtime, and overtime is 1.5 times, oh, that's a $27 per hour. So it's 2 times 27. And so if he works 42 hours in a week, he makes $774 in that week. All right, W of 50. So again, for the first 40 hours, it's $720, plus it's 10 more hours at $27 an hour. And so that total will be $990. Does Isla's equation give you the correct pay for these weeks? Explain. Well, Isla's equation doesn't take into account the overtime, so there's going to be a different rule. When the number of hours is greater than 40, and that rule is going to be $27 times the number of hours. So when we graph this, it's called a piecewise function because there's 2 pieces. The first piece is if Levi works 40 hours or less, and so that slope will be $18 an hour. And we can graph that. So we just need 2 points to graph a line. We can graph these 2 points. Here's our graph for us. So we know at 15 hours that Levi makes $270. So 15 to 70 is like about right there. And at 40 hours, it's 720. 40 hours, it's 720, which is right here. And we start at 0. Oh, see if I can use my line tool here. Oh, gosh. Oh, there we go. Okay, so here the slope is $18 per hour. Okay, and then the slope goes to 27. So again, we just need 2 points to graph a line. So we can just start at this point. We can graph one of our other points. So like the 990 at 50 hours. 50 hours, it's $9.90. All right, so it increases. Put the arrow right there. So here's kind of the cutoff at 40 hours. And the slope becomes more steep here. So again, it's called a piecewise function. There's two pieces. The green and the blue piece are the regular wage and then the overtime wage. So when we write this function up, we can say, all right, the wage after a certain number of hours, the weekly wage, two things. The first one is $18 per hour if 0 is less than or equal to the number of hours, which is less than or equal to 40. But then it becomes $27 per hour when h is greater than 40. So a piecewise function, there's two parts. Here's the function. Oops. Function or rule here. And then over here, this is when it applies. Oopsies. So there's the piecewise function where there's just more than one rule and it's broken into pieces. So quick notes today. Excuse me. Piecewise functions, let's go over the definition. Piecewise functions have two or more equations that apply to different intervals of the domain, to different parts of the domain. All right, so here's how we write it up. So the rule will be, and then you have equation 1, interval, equation 2, your second interval, and so on. You can have more than one as well. All right, so check for understanding. It says a company orders stickers with their company logo on it. The cost of purchasing X stickers is given by this function. What is the cost per sticker when you buy less than 100 stickers? All right, so you have to find when is the domain less than 100, and that's this first part right here. So we're going to use that price, 23 cents a sticker, if it's less than 100. But if you buy more than that, so if you buy 400, it's going to be a little bit cheaper. It's like buying in bulk. So it's 16 cents. And you're going to multiply by 400. Okay, so that's $64 for stickers. And it says find f of 100 minus f of 499. What does this value represent in the context of this problem? Okay, let's find those first. All right, so f of 500. If it's 500, it's going to be 8 cents. So 0.08 times 500 minus 499 is going to be 16 cents times 499. Okay, so we get, this is $40 minus $79.84, which is negative $39.84. So what that means is it's cheaper to get 500 stickers compared to $4.99 because you get a lower price. So cheaper to get the 500. Cheaper to get 500 versus 499 stickers because you get that lower price. Okay, and the last one, the cost of a large pizza at Romano's can be modeled by the function shown. They advertise $12 a large pizza. How many toppings are included in this price? And if you break it down, up to 2 toppings. Okay, and it says, how much does each additional topping cost? Okay, so if we take a look at it, I'm not really sure like the in-between amounts, so we know that when it's $18 when you have 6 toppings. So how many extra toppings is that? 1, 2, 3, 4. So I'm going to take 18 minus 12 and divide by 4. So that's 6 over 4, which is $1.50 more a topping. What happens to the cost when you get more than 6 toppings? It stays the same. And then why do you think Romano's does that? There could be many different reasons for that. Maybe most people do 6 toppings or less, maybe just to keep the price down. All right, so your assignment today, you have the intro of piecewise functions. So if you go to Delta Math, it kind of reviews a few things. Number 1 is function notation. And do you know how to like plug things in, like using function notation like this? And then there's a part of like, can you read a function from a graph? So really the assignment's a lot of review. And tomorrow we'll review these piecewise functions and look at step functions further.